సార్ నాకు యూట్యూబ్ లింక్ వచ్చింది యూట్యూబ్. యా, ఓకే. Hi everyone. So we are going to start TOC today, but before that, all of you join this Telegram channel. Okay, all of you please join the Telegram channel because I will be asking you questions and you will be answering them in the Telegram channel. Okay. I'll be asking you the questions and please answer the questions in the Telegram channel. Okay. Right. So everyone has joined. Now I will not be seeing the comments in YouTube. I'll be seeing the comments in Telegram channel. Okay. So I will give you 2 minutes. Everyone please join the Telegram channel and I will be looking at your answers in the Telegram channel. Okay. I'll be looking at your answers in the Telegram channel. Sir, నాకు చూడండి. Everyone please join Telegram channel. Udaya. Yeah. So I think there is some problem with the settings in Telegram channel. You are not able to comment, right? I think there is problem with the settings in Telegram channel. You are not able to comment. I think there is some problem. Gate DA classes are going to start from. Meanwhile, you join the Telegram channel. So Gate DA classes are going to start from Wednesday. Okay. So for the paid batch, discrete mathematics and probability will be going. Probability for DA and CS and discrete mathematics for CS. And TOC, I will do it on the YouTube channel so that you will know how I teach. Okay. For those people who don't know how I teach, I'm going to teach TOC on the Telegram channel. Sorry, YouTube channel. You can watch it. Okay. I think no one is able to comment. There is some problem with the Telegram channel settings. Let me just do these settings once. Meanwhile, you join the Telegram channel. Hello, hello, hello. Everyone, please join Telegram channel. I will start the class in 5 minutes. Okay. I will start the class. Moving 5,000. Yeah, just a minute, okay? Everyone, please join the channel. But people are not able to comment in the channel. I think I have to do some setting changes. Let me do some setting changes. I'm just setting the Telegram channel, okay? Meanwhile, you please join it. Mm. Only admins are able to post in Telegram channel. Others are not able to. I think something is disabled here. అది టెలిగ్రామ్లో వెళ్ళట్లేదు. సబ్స్క్రైబర్స్ కన్నా చూడాలా. అడ్మిన్సే కొట్టగలుగుతున్నారు, లేదా అడ్మిన్స్ అందరూ అడ్మిన్సే. Telegram channel is not working. Okay, so we are just testing the Telegram channel. Just give me 5 minutes of time. Okay. So Telegram will be available soon. So let's start the topic. Okay. Once the questions start, we will use the Telegram channel, right? Okay. So guys, today we are going to start with TOC. Okay. So TOC is theory of computation. Okay. Now, why is it called theory of computation is? So basically, why should we learn TOC? What is the importance of learning TOC? So you will not understand it now, but once I do Turing machines, you will be able to understand it, right? So basically, TOC is nothing but we want to know what a machine can do and what a machine cannot do. And computer is also a machine, right? So basically, what a machine can do and what a machine cannot do, if you have to answer that question, that is where TOC is going to be useful, and that is why TOC is included in your syllabus. Okay. So the way I will teach TOC will be little bit different from the way you have learnt in your colleges. Okay. So, in colleges, since the subject is theory of computation, mainly theory will be taught in TOC, right? But coming to GATE exam, I am going to cover both the theory as well as the problems, and mostly the questions in TOC will be problem related. Okay. Theory questions will also be there. We will solve all the PYQs, but there will not be too many theory questions. Mainly problems will be the focus. Okay. So I will cover the subject in such a way that it will be useful for your BTech as well as it will be useful for your GATE exam as well. Okay. So guys, coming to TOC, now what is that we have to learn? What is the main things that we are going to see is, first thing is we are going to see what are regular languages. Okay. What are regular languages? So people, those who have registered, you don't have to write the notes. Entire notes will be provided to you. Just watch it. Okay. So first we will see regular languages, and then we will see context free languages, and then we will see Turing machines. Only these three parts. That's it. That is the syllabus. Okay. So 80% of the questions come from regular languages. So we are going to do a lot of problems. Okay. So only in regular languages, I will be giving you 1000 practice questions. More than 1000 practice questions I will give you. Okay. And apart from that, you are going to have, for those who have registered for the course, they are going to get at least 100 questions every day from tomorrow, right? And the difficult practice questions I will discuss with you, or you can write the doubt in the platform and we will answer it. Okay. So every day you are going to get practice questions. So only in regular languages we are going to have hundreds of questions, and context free languages, generally it is 15% of the questions come from context free languages, and Turing machines generally they don't ask every year. Sometimes they may ask, but only 5% of the questions come from Turing machines, because Turing machines is mainly theory. Even though we are going to solve some problems in Turing machines, but the questions which are coming in Turing machines are mainly theory. Okay. Okay, fine. So I will cover everything in TOC, but the order in which I cover will be little bit different from what you have learnt in your college. I will make it in such a way that it will be easy for you to understand. Okay. So I will see that you will be able to understand everything, right? And we are going to start from basics. I assume that you have never seen TOC in your life, and this is the first time you are seeing the TOC. That is my assumption, and I am starting from basics. The reason, every subject I start from basics. Okay. The reason why I start from basics is because there are many people who are having backlogs, especially in TOC and compiler design, right? So people who have backlogs should follow it. And also there are many non-computer science students taking computer science gate. Okay. And so they have to understand it. And just 1 hour of basics I will do, then everyone will be in the same line. Then we will do the problems. Okay. Okay. Yeah. Fine. So where do we start from? So let us take English language. Okay, if you take English language, there is something called as symbols and alphabets, right? So alphabets, so A, B, C, D, all these are alphabets, right? Now each alphabet you can call it as a symbol, right? And in TOC also we have something called as symbols, and there is no restriction on what symbols you want to use in TOC, right? So symbols can be anything in TOC. For example, symbol can be A, symbol can be B, symbol can be C, so on, symbol can be Z, or symbol can be capital A, capital B, capital C, so on Z, and or symbols can be 1, 2, 3, so on 9, or symbols can be even pictures. You can also use pictures as symbols. Okay, anything can be a symbol. You can use special symbols also, right? You can use dollars, you can do hash, but they have some certain significance, right? Generally, it is a convention, not a rule, that we use small letters or 0 to 1 as the symbols, and capital letters are generally capital letters are generally used for state names. Okay, capital letters are generally used for state names, right? Now, among all these symbols available in the world, you pick some of them and then you make something called as alphabet. You make something called as alphabet. Okay, now what is alphabet? Alphabet is a set of symbols. Okay, I can say alphabet is A comma B. I can say alphabet is A comma B. Try to understand it. Symbols can be anything. Now once you choose some symbols, and once we decide that we are going to use only those symbols, then that is called alphabet. And alphabet is always a fixed size set. You cannot have infinite alphabet. Okay, so in GATE exam, most of the questions will have one symbol or two symbols, right? And three symbols are very rare. Okay, so three symbol questions will be asked in basically 3 and 4 symbols will be asked in push down automata, but not in regular languages. But anyway, we are going to see more symbols as well. That's not a big deal. Okay, so we are going to add 3 symbols also, but let me start with 2 symbols. Okay, now there is something called as a string, and you know what is a string, right? What is a string? A string is a sequence of symbols, right? String is a sequence of symbols, right? Now what does that mean? If you take A comma B, what are the various strings you can form? What are the sequences of symbols? You will have A, you will have AB, you will have ABB, or you will have AAA, or you can have anything. Okay, so all these are strings. Okay, now one thing that you have to understand is a string is always fixed length or finite length. Okay, string should always have finite length, right? You cannot say a so on infinite times is a string. This is not a string. String is always a finite length. Okay, now I'm going to start discrete mathematics for GATE CS and probability for GATE DA. Okay, for the paid subscribers. So there are some counting problems asked here. Okay, so what are the counting problems they can ask on the topic string is, they can ask you number of prefixes, number of suffixes, number of subsequences, number of substrings. Okay, so they actually are not a part of TOC, even though I am going to discuss, but let me discuss counting in discrete mathematics and let me discuss counting in GATE DA. Once you know how to count, then it will be easy for me to explain here what are the number of prefixes, suffixes, subsequences, substrings, everything. Again, we are going to get these strings in algorithms. Okay, there also there will be questions on substrings and subsequences, right? So I will not deal with that right now. I will deal with it once I am done with TOC. Movie na dekho set chesta akkada video. So I అయిపోయిందా? Yeah. Okay. So I'm going to teach you counting problems on strings once you understand how to count. Okay. So basically there is a framework that I have built which will make counting very easy. Now what is counting? Basically permutations and combinations is nothing but counting. Okay. So permutations and combinations, I have a framework. Now if you follow that framework, you can do any kind of question in counting. So my framework is different. So I only have created that framework so that it will be easy for you. Now I will teach that framework, and after that I will come to the topic of counting in the strings, right? Let's not do counting now here, okay? Audience bit. Let's not do counting here, okay? I will take it later. Okay. Now you know what is a symbol, what is a alphabet, what is a string. You know all these things, right? Now what is the next thing that you should understand is something called as a language. We are going to work on languages in TOC, okay? Something called as a language, right? So what is a language? Language is nothing but set of strings over the chosen alphabet. Language is set of strings over the chosen alphabet. So whenever you answer any question in GATE exam, first thing that you should understand is what is the alphabet? Without knowing the alphabet, you cannot answer any question, right? So whenever I give you any question, you should ask me what is the alphabet, okay? So alphabet is denoted by sigma. And it can be anything. Let us say A comma B is the alphabet here, right? Now you can form any number of languages, okay? For example, let us say L1 is a language, and it has only one string, which is A. This is not the alphabet, this is the language. Now L1 is a language which has L1 is a language which has L1 is a language which has only one string. See, I am not able to see your comments, okay? So, okay. So, L1 is a language which has only one string A. Okay, it is possible. A language can have only one string. Okay. And then let us say L2 is a language which has two strings A, AB. It is a language, right? Don't think that strings have meaning. They can be meaningless, right? And then let us say L3 is a language. L3 is a language which is set of all strings, starting with A. Set of all strings starting with A, right? Now what are the strings in this language? A, you have to start with A, right? See, first of all, if you are not able to understand anything, don't worry at all. I am going to solve at least 1000 questions, okay, in the class. I am going to solve at least 1000 questions in the class as well as in the practice, okay? So only in TOC, I'll give you thousands of practice questions and I'll solve a lot of questions in the class. So don't worry, this is the first class. If you are not able to understand, don't worry at all. Once I start the problems, you will understand what I'm talking about here, okay? L3 is set of all strings starting with A. Now what are all the set of strings that start with A? A starts with A, AB starts with A, AA starts with A, AAA starts with A, ABB starts with A, ABA starts with A, AAB starts with A, so on, right? Now, what is the difference between L1, L2 and L3? If you observe it, L1 is finite, L1 is finite, and L2 is also finite, right? But if you look at L3, L3 is a infinite language. L3 is a infinite language, right? So what is the meaning of infinite language? A set containing infinite strings and the length of each string is finite. Okay, so always remember one thing, length of every string is always finite. And why is this L3 infinite? Because there are infinite number of strings, you can keep on writing it, it will never end. There are infinite number of strings, it will keep on going, right? So that is how we frame the languages. Okay, that is how we frame the languages. Okay, okay. Fine. So now I will tell you some more basics. Okay, just hold on. We will do some basics for 1 hour, and after that we are going to start the problems. Okay, just let's finish the basics in the first 1 hour, and after that we will start the problems, right? So now we know sigma equal to a comma b is a alphabet, right? So one other way of saying about sigma is also set of all strings, set of all strings, set of all strings of length 1, set of all strings of length 1. Mubin. Set of all strings of length 1, right? Now I can also write sigma power 1, right? Sigma or sigma power 1, both are same. It is nothing but set of all strings of length 1. Now if I write sigma power 2, if I write sigma power 2, it is nothing but sigma concatenated with sigma, right? Now I am introducing a new term called concatenation, right? What is concatenation? Concatenation means attaching, pasting, okay? We are going to concatenate two strings just by pasting them. Now sigma concatenation, this symbol is concatenation, dot is concatenation in TOC, okay? Dot is concatenation in TOC. So sigma power 2 means set of all strings of length 2, okay? So for example, if I have sigma is a comma b, now a comma b is concatenated with a comma b, then what do I get? I get all the possibilities, right? I get AA, I get AB, I get BA, I get BB, right? So AA, AB, BA, BB. What is this? This is set of all strings of length 2, right? Similarly, if I do sigma power 3, let us say sigma power 3, what do we get? Sigma concatenated with sigma concatenated with sigma. And if I write 3 times, then I am going to get set of all strings of length 3, right? So this is nothing but set of all strings, set of all strings of length 3, set of all strings of length 3, right?
Okay, so I can so on go on, and I can write sigma power n. Now what will be sigma power n? Set of all strings of length n. Set of all strings of length 1, right? Length n. So 1 length string, 2 length string, 3 length string, n length string. You can form any length strings by taking the powers of sigma. Now there is a special symbol in TOC which is called epsilon. It is very important symbol, and a lot of gate questions are asked on epsilon questions, right? So almost every regular language question will include epsilon. Okay, so epsilon is also called as empty string. Empty string, right? Epsilon is also called as empty string, and length of epsilon is 0. If you ask me what is the length of epsilon, the length of epsilon is 0, right? Right? So let's not use the name empty string. It will be confusing for you. Okay, let's use a different name for the entire TOC. Different books have different conventions, so let's not use the name empty string. Let's use the string null string. Let's use the name null string. Okay, because empty set you will get confused with it. Okay, so for the sake of understanding, I am going to use epsilon, which is called as null string, and the length of the null string is 0. Now why am I, even though it is an empty string, why am I using null string in the name is because there is something called as empty set. This is nothing but phi. These two are important symbols. Okay, try to understand this. Epsilon is a null string and length of the null string is 0, and an empty set is represented by phi, and what you should understand is epsilon is not equal to phi. Okay, so now you might be little bit confused. Don't worry, when I take problems all these concepts will come again and you will be able to understand the difference between null string as well as empty string, empty set. Okay, which is phi. Okay, null string and null string and phi, you will understand it. Okay, fine, and understand that phi is not equal to epsilon. Phi and epsilon both are not equal, and length of the phi is 0. Now if I take the alphabet and I raise it to the power of 0, I am not going to get empty set, I am going to get epsilon. Okay, 5 raised to the power 0 is nothing but epsilon. Anything when you raise it to the power 0, you are going to get epsilon. Okay, so now what did we learn in this slide? In this slide I have given you a new thing. సరే మూవీ వదిలేసే అందరు. So sigma power 0, unmute చేసావా? Sigma power 0 is equal to empty string. Okay, so here you have learned something called as concatenation. Okay, concatenation. Now there are few things that you have to understand about concatenation. If I take A and concatenate with B, I will get a string AB, right? But this is not equal to BA. Okay, we'll discuss these properties again. Okay, this is not equal to BA. If I concatenate A with B, I will get AB, but this is not equal to BA. Okay. For example, if I concatenate AA with AB, I am going to get AA, AB. So this is simple. Concatenation means just attaching. Okay. Just sticking them together. That is concatenation. That is the only thing that we have learned here. Right. These are all operations. I am going to take one by one. Now, one important property or interesting property is if I take epsilon and if I concatenate with A, then I am going to get A. If I take A and if I concatenate with epsilon, I am going to get A. Okay. If I take epsilon and concatenate with A, I am going to get A. You concatenate it both sides, I am going to get A. Okay. But phi is little bit different. If I take phi, which is empty set, and if I concatenate with A, I am going to get phi. If I take A and if I concatenate with phi, I am going to get phi. And if I take phi and concatenate with A, both sides, I will get phi, right? So all these things you will get used once we start solving lot of problems, okay? So don't worry if you are not able to understand something now, you will understand everything soon, okay? Okay, cool, cool. So properties we will see, okay? I don't want to talk about properties right away. Let's get into it slow, bit by bit. Don't worry, I will discuss everything in TOC, but not in the first class, okay? In the first class, I will make it simple for you, make you get used to it. Then we will go to the difficult problems, okay? So now I am going to introduce something called as star, right? Sigma power star. So the star is called as Kleene closure. Okay. So don't get confused. There are many things I am introducing, but we are going to use all of these in the problems. Then you will get used. Okay. Star means Kleene closure, not CLEAN, clean. It is Kleene closure. Okay. Star is nothing but Kleene closure. Right. Movie అన్ని వర్క్ చేస్తున్నాయా టెలిగ్రామ్ అన్ని ఆయన వెళ్ళిపోతుంది. సో లాస్ట్లో అది ఎండ్ కొట్టమే కదా. Okay. Star is nothing but Kleene closure. Kleene is name of a scientist. Okay, it doesn't have any meaning. This is name of a scientist. Now whenever you get star anywhere, you can put any number in it. You can put 0, you can put 1, you can put 2, you can put 3, you can put any number. So what do I mean by that? So sigma power star is nothing but sigma power 0 union sigma power 1 union sigma power 2 union sigma power 3, so on up to infinity, right? Wherever you say star, wherever you see star, put 0, 1, 2, 3 and you take union of all this, right? Now we have already seen sigma power 0 is nothing but epsilon, which means string of length 0, right? And sigma power 1, you already know it is set of all strings of length 1, right? And sigma power 2, you already know it is set of all strings of length 2, right? And sigma power 3, you already know it is set of all strings of length 3, okay? Now whenever I talk about sigma, let us assume something. Let us say sigma equal to a comma b, right? It is set of all strings of length 0, length 1, length 2, length 3, so on. So what can you say about sigma star? Sigma star is nothing but set of all strings, set of all strings possible, set of all strings possible over sigma. Sigma star is what? Set of all strings possible over sigma. 0 length string, 1 length string, 2 length string, 3 length string, so on. It is set of all strings possible over sigma, right? Now this is also called as universal set. Universal set. Okay? Universal set, which means every string possible over this alphabet will be in the universal set, and the universal set is sigma star, right? And in TOC, we are going to take subset of sigma star, okay? We are going to take some strings and we will work on them. Let us say this is language 1, right? This is all strings possible. From that I have taken a language and I will work on it, right? And now there can be many number of languages, right? Now again some counting is required here, right? So there are some concepts which I am not going to touch now because I have to go to Turing machines. There I will explain them, okay? So there is something called as countable, countably infinite, countably finite, okay? Okay, right? So again in discrete mathematics we are going to study about the set theory, but just for the sake of understanding, how many languages are there in this? How many languages are there in this? See, if set of all strings possible is sigma star, then how many subsets are there in this language? 2 power sigma star, infinite number of languages, right? We will discuss about it after I finish discrete mathematics, because I want you to understand some concepts of counting here, okay? One thing is clear, sigma star is infinite, right? So there are infinite number of strings, and 2 power sigma star is definitely going to be infinite. Power set, what is power set? Set of all subsets, right? Okay, I don't want to confuse you now. Okay, I am not saying anything. Okay, leave it. I didn't say anything, just leave it. I don't want to confuse you, okay? You understand what is sigma star? Set of all strings. And what is a language? Language is a subset of sigma star. Just understand that, okay? Any language is a subset of sigma star. Just understand this. I didn't talk about counting. I didn't tell whether it is countably finite or countably infinite. I will not talk about it until I reach a point where I can talk about it, okay? With proofs. I'm going to do it with proofs, okay? I'm going to do it with proofs. Udaya, water. Okay. So I'm going to do everything with proofs. Okay. But not now. I want you to understand mathematics a little bit. After understanding counting, we'll see a lot of problems in TOC, right? So the problem is discrete mathematics questions are asked in TOC. You may think that they are TOC questions, but they are discrete mathematics questions, right? For example, if I say how many DFAs are possible with 2 states? Now by looking at DFA, all the PYQ books, they will write that problem in TOC, but that is actually a counting problem, right? That is a discrete mathematics problem, right? So that is why I will solve such questions after I teach discrete mathematics. So that is why I have started discrete mathematics in parallel with TOC, so that you will know how to count, and then we will apply that counting in TOC. They are not TOC questions, they are counting questions, but they can be asked in TOC, right? Number of substrings, number of subsequences, number of prefixes, number of suffixes, number of NFAs, number of DFAs. All these questions are counting questions. You have to learn counting first, then we will apply here. Okay, I am not going to do it now. Okay, I am not going to confuse you now. Let's stick to TOC part. Okay, once I finish counting in discrete mathematics for the paid users, then I will come back here and I will teach all the problems in counting. All the problems in counting related to TOC we will do. Okay. Yeah. So now let us see one thing. Okay. So I'm going to give you the entire overview of regular languages and I will go into each one by one. You will not be able to understand now. Okay, if I say regular languages, you don't know what is a regular language, but say regular languages or some kind of languages. Okay, now what are the things that we are going to learn when we are talking about regular languages? What are the things that we are going to learn when we are talking about regular languages? Okay, so regular languages can be represented. Regular languages can be represented by regular expressions. You don't know what are regular expressions? I will teach you, don't worry. Okay, it is just the high level overview of what are all the things we need to learn in regular languages. What are all the things we need to learn in regular languages? Okay, so regular expressions are what? Representers, right? And then we have something called as acceptors. Acceptors, right? So acceptors are nothing but machines. Acceptors are nothing but machines, right? So regular expression represents a language, and these acceptors, which are machines, will say whether a string is in the regular language, yes or no, right? These machines will answer you the question yes or no, right? Now these are called as finite automata. These are called as finite automata. I know you are not understanding anything. It is just the overview. I will break it into small parts and we will discuss each of the small part one by one. Okay. So finite automata are the acceptors. Now when you look at finite automata, again there are two categories. One category is without output and other category is with output, right? Now without output is divided into three categories. DFA, which is called deterministic finite automata, NFA, which is called non-deterministic finite automata, epsilon NFA, which is also a kind of NFA, but it will also contain epsilon, right? Now these machines will not give you any output. They will only say yes or no. Yes, the language, yes, the string is in the language. No, the string is not in the language. Now there are some machines which will take input and they will give output, right? So whenever there is a machine, right, if you give a input string, is it visible? Is this part visible? I will just see. Yeah, this part is visible, right? So whenever I give a input string, okay, and if the machine says yes or if the machine says yes or no and no output, they are without output machines, right? Now generally when you take a input string, when you give a input string to a finite automata or to a machine, let us say this is a machine, okay, we don't care what machine it is, okay, I have taken the input string and I have given it to a machine and it has given me some output, right? Now these machines are generally called as transducers, okay. Whenever input is converted to output, we call such a machine as transducer. Transducer, okay. Now finite automata with output are transducers, and there are two types of machines here, okay. One is called Mealy machine and other is called Murray machine. One machine is called Mealy, other machine is called Murray, right? So then there is something called as generator. So what is a generator? Generator will generate the language, entire language. A representer will represent the entire language in a short and concise way. Acceptors are machines which will say whether the string is in the language or not in the language, or they may convert the input to output. These are the machines. Now coming to generator, they are little bit different, okay? So these are called as regular grammars. These are called as regular grammars. These are called as regular grammars, okay? Now again, regular grammars are classified into two types: right linear grammar and left linear grammar. Right linear grammar and left linear grammar, right? So this is the most important. This is all about, if you study all of this, regular languages are over. If you study all of this, regular languages are over, and 80% of the questions and 80% of the questions in TOC will come from here, right? Right? Now, you have to understand everything here, right? So, what is my method of teaching? How do I teach is, most important questions in GATE, they come from DFA and NFA and regular expressions, right? So first we will look into DFA and NFA along with regular expressions. I will do these two in parallel so that you will get to know how we are going to write DFA, NFA and regular expressions. And then I will go into regular expressions in detail, in depth. Okay. Now the other parts, let me use a different color. Now second part which I will discuss, is regular grammars. This is the second part that I will discuss. And then the third part I will discuss is Mealy and Murray questions, right? So this is Mealy and Murray questions. So regular grammars will be foundation for context-free grammars. Even though direct questions are not very frequent on regular grammars, if you understand regular grammars, you will be able to write context-free grammars which are frequently asked. Now, Mealy and Murray are not very frequently asked. In the entire PYQs, only 3-4 questions will be there, or I think only 3 questions are there in Mealy and Murray. Okay, right? So, we will do in this order. First, take NFA, DFA, take regular expressions, put them together, solve the equations, right? And then we will go to regular grammars, and then we will go to Mealy and Murray. Now, when I am teaching DFA and NFA, you will learn some part of regular expressions. Then I will go into very high detail about regular expressions. I will take a lot of classes only on regular expressions because it is the most confusing. Even though DFA, NFA and regular expressions are very frequent, you will get confused in regular expressions a lot. So I will be doing a lot of questions on regular expressions. You can expect at least 10 hours of lectures on regular expressions, okay? Or at least 8 hours. 8 hours I will teach only regular expressions, right? No one will teach you regular expressions for 8 hours. Go anywhere and see. No one will teach you regular expressions for 8 hours, right? But I will focus there because that is where people will fail, okay? That is where people generally fail. So I am going to focus there, okay? Fine. Fine. Now I want to solve problems. I want to solve problems by taking DFA, by taking NFA and by taking regular expressions. But before that, you should know what is a DFA, what is a NFA, what are regular expressions. So let's understand what is DFA, what is NFA, what is regular, and then trust me, you are going to love the class after this. Once I finish DFA, NFA and regular expressions, trust me, you will enjoy the questions like anything. Okay. Now we are just doing the basics. Once I start questions, everything is a puzzle. I will come up with lot of answers, you will come up with lot of answers, there will be arguments, people will be quarreling in telegram channel that my answer is right, your answer is right. So it is going to be really fun. Okay, let's start. Okay, so just understand what is DFA, what is NFA, what is regular expression, then we are going to start problems, and trust me, you will love it. Okay, you will love it. Okay, so let us say DFA. Let us see DFA, deterministic finite automata, deterministic finite automata, DFA, right? So tomorrow I am going to upload 100 practice questions, right? You may not be able to solve all the practice questions, but the difficult problems I will solve here, but you practice them. I will give you only questions, not the answers. Every day I will give you questions. You solve it on your own. Next day I will give you answers. Okay. Tomorrow you are going to get 100 practice questions for the paid users in the paid platform. Okay. Now you solve those 100 questions. Then I will give you the solution. Right. Every day, almost every day, you will get 100 questions. Even though I'll start slowly, but almost on a daily basis, you will get hundreds of questions. Okay. Okay. Now see this deterministic finite automata, which is called DFA. Okay. DFA is called deterministic finite automata. Now the question is, what do you mean by deterministic? Right. Deterministic means unambiguous, or deterministic means it is fixed, right? So I'll just give you one example to understand what is deterministic, right? So you represent a DFA or NFA or epsilon NFA using 5 things. DFA is represented by 5 things. Okay, Q, sigma, delta, Q naught and F. Okay. Now if you understand what are all these, see this is a tuple, right? In discrete mathematics, this is called a tuple or a set. It is not a set, it is a tuple because it is ordered. An ordered set is nothing but a tuple. Now how many elements are there? 1, 2, 3, 4, 5, right? 5 means quin. 5 is also called as quin. Therefore, this is called a quintuple, right? There may be some questions on definitions also. So don't ignore theory in theory of computation. Even though we are focusing a lot on problems, don't ignore theory, right? 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 Okay. So it is a quintuple, which means 1, 2, 3, 4, 5. Now, if you understand all these 5, you can answer any theory questions, right? Now, what do I mean by deterministic is every state for every input symbol in the alphabet, it will go to only one state, exactly one state. I can say only one state, I can say exactly one state. Okay. So let's take an example and see. Okay. Now, whenever I give you any question in TOC, what is the first thing you should ask me? Sir, what is sigma? Sigma is nothing but the alphabet. So give us the alphabet. Okay, let us say A comma B is the alphabet. Okay, this part is clear. You know already sigma, right? Right? Okay, fine. Now, what is Q? Right? So let us take an example and let us see that. Okay. So let us say I have a DFA like this. You don't know what is a DFA, but then I'm just giving you some example. Okay. You don't have to understand what it is doing and all that. We will see that later. Okay. Okay. Now let us say the states are A, B and C. Okay. Now what is Q? Q is nothing but finite set of states. Q is nothing but finite set of states. Finite set of states. How many states are there? A is a state, B is a state, C is a state. Therefore, in this example, Q is nothing but A, B and C. 3 states. Right? Now, whenever you see arrow, so this is called as state transition diagram. Whatever I have written here is called as state transition diagram. State transition diagram. There are states, there are transitions. Therefore, this is called as state transition diagram. State transition diagram, right? Q is what? Finite set of states. Now, why is finite automata called finite automata? Because the number of states are finite. This finite comes from the fact that the number of states are finite. Okay. What is the meaning of automata? Automata means a machine. A machine is also called as a automata. A machine is also called as a automata. Now you have to ask me, why is it called deterministic? Okay. Again, I have to go to a topic which I will discuss in discrete mathematics, and okay, so that is for the paid batches. There we are going to see something called as sets, relations and functions. Okay. Now I will not go into depth of that. I will just explain you what is required here. Okay. So now let us see the simple things. Okay. So Q naught. What is Q naught? Q naught is nothing but the starting state. Okay. Q naught is nothing but the starting state. Now when I say a starting state, it is clearly one element. It is not a set. Always starting state will be only one element. Any machine in TOC cannot have more than one starting state. Take any machine. Okay. Now in STD, state transition diagram, whenever you put an arrow, right, that represents the starting state. Therefore, here Q naught is the starting state, which is equal to A. Q naught is the starting state, which is equal to A. Now, F, capital F. Now, this is a set. Remember that this is a set of final states, right? Now, in the SDT, wherever you see double circle, that is a final state. Wherever you see a double circle, that is a final state. Now, I said set of final states, right? Now, set of final states, already states are finite, right? You can also say it is a set of states, which means it is definitely subset of Q. Therefore, F is finite. And one thing that you have to understand is, when I say F is finite, it can be empty, or it can contain one state, or it can contain many states. When I say the word set, it is very important. Okay. So, final states, number of final states is a set. It can have 0 elements. There need not be any final state for automata. It is not accepting anything. Or it can have one state. There can be only one final state. In this example, there is only one final state, right? Or there can be more, 0 or 1 or more. Obviously, it is a set of states, and set of states are finite. Therefore, it cannot be infinite. It is a finite set. Okay, final states is also a finite state. It cannot be infinite because we don't have infinite number of states. Where do you get infinite number of final states? Okay. 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 Now what did you understand? Now what did you understand? Tell me. Okay. So in the definition of DFA, you understood Q. Q is nothing but set of all states which is finite, and sigma. Sigma is also finite and non-empty. Okay. So sigma is A comma B, and you understood Q naught. Q naught is nothing but a single state. It is not a set. And you understood F. F is nothing but set of final states. It can be 0 or 1 or more. Only thing that varies in every finite automata, when you are talking about DFA, NFA, epsilon NFA, all these are same. All these are same. So I am not going to repeat it. Okay. Only thing that changes is this delta. Okay. Now if you have to understand delta, you have to understand functions in discrete mathematics. That is why I am starting discrete mathematics, because discrete mathematics is applied in various subjects in various forms, right? Discrete mathematics is applied in every subject in various forms, right? uh, so I'll give you a lot of examples. Okay. Okay. So now we have to understand delta, right? So what is delta? Delta is a transition function. Delta is a transition function, right? Now I am using the word function, which, if you have to understand function, you have to understand relationships, and then types of functions, types of relations. All this will be discussed in detail in discrete mathematics for the paid users. Now, transition function, all right? So we are talking about a function, right? Now what is this function? This function delta, delta is a function from q cross sigma to q. Delta is a function from q cross sigma to q. Okay. Now since it is a function, function is always a mapping from one set to the other set. Let us write it like sets. Let us write it like sets. Okay. Now tell me what is q. Q you know already, A, B, C, right? Q is A, B, C, and sigma you know. What is sigma? A, comma, B. Now take the cross product of it. ABC cross product with AB. What do you get? 3 elements here, 2 elements here. There are 3 elements here. There are 2 elements here, right? So you get 6 elements. What are they? A comma A comma B. See, when I cross product two sets, I will get ordered pairs. So don't worry about this terminology. I will discuss in discrete mathematics in detail. So just cross product, what do you get? A, B, B, A, B, A, and then C, A, and then C, B, C, B, right? So when I cross product this with this, I got this set. This is a set of ordered pairs. Now delta is a function which is taking these ordered pairs and going to the set Q. What is Q? A, B, C set of states. A, B, C, right? Now try to understand what happens, okay? Now try to understand what happens. Capital A on small a is going to B. Capital A on small a is going to B. Therefore, I will put a arrow like this. Now, capital A on small b is going to C. Capital A on small b is going to C. Now, capital B on small a, capital B on small a and small b is going to be. So I have missed out one thing here, okay? B comma B, C comma A, C comma B, okay? So capital B on A comma B is going to B only. So capital B on A is going to be, and on B is going to be B only. Now capital C on A comma B is going to C only. So capital C on A comma B is going to C. Right? 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 Now if you observe it, every state on every input will go to exactly one state. It will not go to 0 states or it will not go to more states, because every element in Q is a single element, and in a function every element here should have an image here, right? So this is delta. Delta looks like this. Delta looks like this, right? 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 Okay. Now the question is, this is called as state transition diagram. This is one way to represent a DFA, and this is called as state transition function. This is one way to represent a DFA, and then there is one more way to represent a DFA, which is called as state transition table. Okay, there is something called as state transition table. Okay, so state transition table in the exam, you may get this, you may get this, or you may get this. You have to understand all three. All three are representing the same machine. Okay, so what are the three states? The states are A, B, C. Okay, now what is the initial state? The initial state is A. So whenever the initial state is there, you are going to put a arrow. Okay, what is the final state? B. So whenever there is a final state, in the state transition diagram you put double circle, and in the state transition table you put a star. That's it. Okay, now what are the input alphabet, A or B? Right, now see this, capital A on small a is going to be, okay, capital A on small a is going to be, capital A on small b is going to C, and capital B on small a and small b is going to be, right? Capital B on small a and small b is going to be, and capital C on small a and small b is going to C. This is called state transition table, right? So this is the story of DFA, right? And now when we see the questions, you will love them. Okay, now I'm not going to take this entire story for NFA. For NFA, I'll just explain you what is the transition function, and everything is same, right? So Q sigma delta Q naught F, everything is going to be same. So in NFA, I'm not going to explain you the entire story. Okay, and remember one thing, now you are sitting and watching for a long time. That is not good for you. I will give you 3 minutes break. 3 minutes break. Just stand up, everyone. Stand up. Stand up. Right? Do this. 1, 2, 3, 4, 10 times. Okay? Okay? And then do this. Okay? 10 times. One way and 10 times other way. Okay? And then stand like this and do this. Do this. Okay, for 3 minutes you do these workouts. That will free up your backbone and your shoulders. Okay, and rotate your shoulders, and do neck exercise. Okay, for 3 minutes you do this. Okay, we'll start. 3 minutes you just do some workout. Don't sit. Okay, you will be like KFC chicken. Just move. Okay, I'm giving you 3 minutes break. After that, we are going to see NFA, regular expressions, and we are going to start problems. Okay. Okay. Okay, guys. So from Wednesday, I'm going to start discrete mathematics, and discrete mathematics for gate CS, which will be for the paid users, and then probability for gate DA, which will be for paid users. That will happen on our platforms, right? TOC will happen here. Okay. It is a free course for the community. So I'm going to do the entire TOC subject, uh, everything here. But only thing is, for free users, you will not be getting practice questions, and for paid users, you will be getting hundreds of practice questions every day, which will help your preparation. Okay. So this is about the DFA, right? Now let us see about non-deterministic finite automata. Okay. Let us see about non-deterministic finite automata. Now, what is non-deterministic mean? Non-deterministic means that if a state on seeing a symbol may not go to any state, may go to one state or may go to more, right? Which means a state can go to 0 states or go to one state, or it can also go to more states, right? So I will just take an example, a very good example, right? For example, this, right? So I'll just take a simple example, right? Let me say a comma b. Okay, let us say this is state A and this is state B, right? And it is also a quintuple. NFA is also a quintuple. Q sigma delta Q naught and F. Okay, so what is Q here? Set of all states. How many states are there? Only two states, A comma B. I'm not going to repeat the definitions. You see the definitions in DFA. Okay, now what is sigma? Sigma is A comma B, the input alphabet, right? And what is Q naught? Q naught is the starting state. So what is the starting state? It is not a set, it is one single element. And what is F? F is a set of final states. And what are the final states here? Only B. That's it. Okay. Only thing that you have to understand is delta. Now here delta is Q cross sigma to. So if you can understand that, I have increased the speed. Okay, now that you understood everything about DFA, I have increased the speed. I will keep on increasing the speed once you get the basics. Q cross sigma to 2 power Q, right? Now what is Q cross sigma, guys? What is Q? So Q is AB, and what is sigma, guys? Sigma is AB, right? Now if I take the Cartesian product of it, what is the set I'm getting? Set of ordered pairs. What are the ordered pairs I get? A is one order pair, B is one order pair, BA is one order pair, BA is one order pair, and BB is one order pair. Now what is 2 power sigma, guys? 2 power sigma is nothing but power set of Q, right? What is 2 power sigma? Power set of Q. What is power set? We will discuss in discrete mathematics, right? It is nothing but set of all subsets, right? So what are the set of all subsets of Q, guys? Empty set is always a subset of anything, and one element subsets, and then one element subsets, and then two element subsets A comma B, right? Now just look at this state transition diagram. This is called state transition diagram, and this is called state transition function. Right? Now capital A on seeing small a is going to A as well as going to B, which means capital A on seeing A is going to A comma B. Now capital A on seeing B is going to A. Capital A on seeing B is going to A, right? Capital B on seeing A or B not going anywhere, right? Which means it is going here, right? So now if you observe it, a state on seeing a symbol can go to multiple states, or need not go to any state, or it can go to one state. That is why sigma power Q to 2 power Q. This is NFA. Right? And we know that these two elements are nothing but the elements of the cube, right? These two elements are nothing but the elements of cube. Therefore, NFA definition also includes DFA. Now in the previous example, if you see, even if you write 2 power q, right? You have A, you have B, you have C. Here also you have A, you have B. Therefore, NFA definition covers the DFA definition also. Why? See this, here you have only ABC. Here also you have AB separately. Therefore, NFA definition covers DFA also, right? So, I can write like this. Every DFA is also, I will use a different color, okay? This is the most important point that you have to understand, okay? So, what is the most important point? Every DFA is also NFA, but every NFA need not be DFA. Try to understand these 2 points. If I give you a DFA, you can also call it an NFA. But if I give you an NFA, it may or may not be DFA. This is the classic example. Can you call it a DFA? You cannot call it a DFA because there is no determinism here. There is non-determinism. A on seeing A is going to 2 states. Capital A on seeing A is going to 2 states, non-determinism. And capital B is not going anywhere, non-determinism, right? But here you can call, where is this? Yeah, here. You can call this NFA because there are no rules for NFA. It is going to 1 state, okay? So every DFA is also an NFA, but every NFA need not be DFA. But funny part is, this is very important thing to note. This is very important thing to note, right? The funny part is DFA and NFA both are equal in power. DFA and NFA both are equal in power, which means if a language is accepted by DFA, you can give a NFA, and if a language is accepted by NFA, you can give a DFA, right? Now similarly, you can also put, see what is this guys? State transition diagram. What is this guys? State transition function, right? This is state transition diagram, right? This is state transition diagram and this is state transition function. This is state transition diagram and this is state transition function, right? Right? You can also give state transition table for NFA also, right? Let's give a state transition function table, state transition table, right? So A and B are the states. A is the initial state, cool. A is the initial state. B is the final state, cool. B is the final state. What are the input symbols? A, B, right? Now, capital A on seeing small a is going to both A and B. So, I will write A comma B, right? And capital A on seeing B is going to only A. So, I can write A. In the exam, you may get this, or you may get this. Now, capital B on seeing A or B is not going anywhere. So, I can write phi and phi. That's it. This is non-deterministic machine, right? Every DFA is also an NFA. If a language is accepted by DFA, it will be accepted by NFA. If a language is accepted by NFA, it is accepted by DFA. All these points you should be knowing them, okay? These are all the basics. All these points you should be knowing very well, thoroughly. Thoroughly you should know them, okay? And then there is one more finite automata, which is not very important. Till now, no gate question has been asked in this. Okay. Till now, no gate question has been asked on something called as epsilon NFA. Right. Let me use a different color. Till now, no gate question has been asked on something called as epsilon NFA. No gate question till now. Okay. So we will not look into it, or we will not do anything with it. We will not do any practice questions also on it. I'll give you a few practice questions, but yeah, it is not asked in gate. Okay. So it is also same Q, sigma, delta, Q naught, F. Okay. Only thing that changes here is delta. Now, what is the delta here? Delta is a function from Q cross sigma union epsilon to 2 power Q. That's it. So, what is the meaning? A state can see a symbol and can go to any number of states, or a state without seeing a symbol also can go to any number of states. There are no gate questions on it, and this is not discussed in most of the textbooks also. So this is not important for gate. We will not really look at it. Okay. So now we are done with NFA and DFA, right? So if I give you a machine, you will be able to say whether it is NFA or DFA, right? Tell me what this machine is. Okay. Tell me what this machine is, NFA or DFA. Write it in the Telegram channel. Okay. Or you can write it in YouTube chat. Okay. Is this a DFA or NFA, guys? Is this a DFA or NFA? Is this a DFA or NFA? Is this a DFA or NFA? Write in the comments. No one is writing. Wow. Div, very good. Right? So, whenever I give you a question, don't think, just say NFA. Just say NFA. Right? If there are no epsilon symbols, just say NFA, because it fits. NFA is having a wider definition, right? So every machine, if it doesn't have epsilon, it is a NFA. Now then you think whether it is DFA or not. Yes, it is DFA as well. Why? Because every state on every symbol is going to one state only. Simple logic. Now tell me about this, guys. Okay. So I am writing like this. Is this a NFA or a DFA? Is this NFA or a DFA? Write in the comments. Is this NFA or a DFA? Very good. First thing you should say is any machine I give is definitely NFA, right? NFA has a very wide range of acceptance. Now you think whether it is DFA or not. Is it a DFA? Take every state and every symbol. See this? A on small a is going to one state, A on small b is going to one state, right? And also you should ask me sigma every time, okay? So let us assume that sigma equal to a comma b, okay? Now b on small a is going to b, and b on small b is also going to be. B on small a is going to be, and B on small b is also going to be, right? Therefore, it is DFA also. It is both NFA as well as DFA. Now tell me about this, okay? So let us say I am writing a comma b, and then a, and then I am writing a comma b, okay? So let us say this is state A, this is state B, and sigma equal to a comma b. Is this NFA or DFA? Tell me. 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 Very good. Excellent. Excellent. It is not both, okay? So, first thing you say is it is NFA. Okay, fine. Now, is it DFA? It is not a DFA. Why is it not a DFA? Now, if you see a capital A, on seeing small a, it is one going to A and it is also going to B. A DFA cannot do this. A DFA on seeing a single state on seeing a symbol will should not go to two different states. It is not a DFA. Now you understood the difference between NFAs and DFAs, right? Right? You understood clearly the difference between NFA and DFA, right? Now I'll give you some few points which you will not understand now. You will understand later, but still take these points, okay? But still take these points, okay? Those who have registered for the course, don't write the notes because we are providing you the entire PDF that I am teaching here along with the handwritten notes, very beautiful handwritten notes, and also a typed notes. You are going to get three things. The thing that is written on the board, this entire PDF I will provide you for the paid users, and also a handwritten notes will be provided to you, and also a printed copy of the handwritten notes will be provided to you, okay? Everything will be provided. Don't write the notes. For those who are on YouTube, please write down the notes, okay? Now the point is if I have a regular language, there can be, if I have a regular language, there can be many DFAs. DFAs can be many, right? There can be many NFAs. NFAs can be many, right? But minimal DFA, the smallest DFA that you can make with least number of states, minimal DFA is always unique, right? That is why in GATE exam, they will always ask you about minimal DFA because it is always unique, right? But then in NFA, I will show you with problems also. I'll give you examples, okay? Minimal NFA need not be unique, right? Right? What does it mean? For a language, for a given regular language, there can, not will, there can, not will, हो सकता है, जरूरी नहीं है, ठीक है? There can, not will. There, for a given regular language, there can be many minimal NFA, right? And every minimal NFA has same number of states. Based on this, they can ask you any question. They can ask you minimal DFA, or they can ask you which of the following. It can be an MSQ question, okay? MSQs are very important. We are going to focus on MSQs. And minimal NFA can be an MSQ question because there can be many minimal NFAs and all of them will have same number of states. Now you should understand, given a language, how to design minimal NFA, okay? The problem is given a DFA, in order to convert into minimal DFA, we have an algorithm. Right? But then, and this given a NFA, in order to convert into minimal NFA, we don't have an algorithm, right? Therefore, this question will be asked frequently, right? I hope you understood everything about minimal NFA and minimal DFA. Now, interesting thing will be designing minimal NFA and minimal DFA without using algorithms, with using common sense. By using common sense, if you are able to design minimal NFA and minimal DFA, that will be fun. Trust me, the fun is going to start in 10 minutes. In 10 minutes, you are going to enjoy the class like anything. Okay? Just put on the seat belts. We are going to take off. Okay? In 10 minutes. Okay? Okay. So what is CS, guys? So what is gate CS? What is gate CS? What does CS stand for? What does CS stand for? What is gate CS? What does CS stand for? Very good. I am the one who made computer science a common sense. Okay? So it is all common sense. Okay, cool. So now let us see regular expressions and we will directly jump into questions. Just give me 2 minutes. We are going to start. Okay? We are going to start in 2 minutes. Just a small concept, regular expressions. Okay? I will take a detailed 8-hour lecture on regular expressions, but now I will just give you overview. Okay? Just understand this. Operators. What are the operators in regular expression, right? So operators are, one is plus and this is called union. Union inset you know, right? Union inset you know, right? And 2 is dot. This is called concatenation. This you know, we have already seen it. And 3 is called star, which is called clean closure. You already know this. You already know this. Right? Right? Now, 5 empty set, epsilon null string, and any symbol that belongs to sigma, all these are called as primitive regular expressions. Primitive regular expressions. Right? Right? Primitive regular expressions. Now, once you have these primitive regular expressions, let R1 comma R2, let us say R1 comma R2 are regular expressions, then R1 plus R2 or R1 dot R2 or R1 star, all these are regular expressions, right? Regular expressions. Now this plus can be used in 2 ways. Okay, so there is one more plus. It is called positive closure. It is called positive closure, right? Let's see some few examples in regular expressions and then we will jump on to the questions, right? So if I say regular expression is A, let us say sigma equal to, okay, I'll write it down. Let us say sigma equal to A comma B. Okay, let us say sigma equal to A comma B. Okay, now if I say regular expression equal to epsilon, right, I will write like this. If I say regular expression and language, okay, if I say regular expression is epsilon, then language is, it is representing is epsilon. The language it is representing is epsilon, right? If I say phi, the language it is representing is empty set, right? Now if I say A, the language it is representing is symbol A. if I say A star, what is the language it is representing? I told you that whenever you see a star, put 0, 1, 2, 3, 4, so on, infinite, right? So it is representing a power 0, which is epsilon. Whenever you get a star, you are going to get a epsilon. A power 1, a power 2, a power 3, so on, infinite language, right? In a regular expression without having a star, you can never form a infinite language, right? So whenever you see a star, put 0 in it, put 1 in it, put 2 in it, put 3 in it, so on. Now if I write A plus, this is called positive closure. You have to put 1, 2, 3, so on. You cannot put a 0, right? Therefore, it is going to be so on, right? Now if I put A star, now if I put A star B, what is the meaning of it? So A star is nothing but A epsilon, let us say epsilon A, so on. Now followed by a B. So if I concatenate with B, now just concatenate it. It is very important to know that this part is in the left and this part is in the right. This part is in the left, this part is in the right. Okay. Now what is epsilon concatenated with B? Epsilon concatenated with B is B, right? Okay. Now what is A concatenated with B? It is AB. What is AA concatenated with B? It is AAB, and then AAAB, so on, right? Right? So that is how you understand the regular expression. But we are not going to go deep into regular expressions now. I will take 8 hours of classes only on regular expressions because it is little bit difficult to understand. Okay. Now what we will do is, now the class is going to start. Okay. All of you have come into the airport. From the airport, you boarded the flight, and now the seat belts are tight. Let's start flying. From now onwards, you are going to love TOC, you are going to love me, right? You will love me, you will remember these classes, and you will miss my classes once the classes are over. Okay. Now we are going to start the problems. We are ready. Okay. Take 2 minutes break or 3 minutes break. Get coffee or whatever you want. We are going to solve the problems now. Okay. It will be fantastic, amazing. If you don't say you don't love it, I'll stop teaching. Anyone in the comments say, I am not loving the class, I will leave teaching. Okay. Let's start it. Let's see, guys. Okay. Don't see the time. It may be 11, it may be 12, it may be 1. I'm not going to stop. Okay. పోతా పోతా పైసలన్నీ పట్టుకపోతావారా, పొరి పొరి అంట దాన్ని చుట్టుకుంటావారా? I don't know the third line. పోతా పోతా పైసలన్నీ పట్టుకపోతావారా, పొరి పొరి అంట దాన్ని చుట్టుకుంటావారా? What is the third line, guys? పోతా పోతా పైసలన్నీ పట్టుకపోతావారా? Of course, epsilon concatenated with B is B. That is what? Right? Epsilon concatenated with B is B. B concatenated with epsilon is B. Epsilon concatenated with B concatenated with epsilon is B. Right? All of you get up, do stretchings, get coffee. We are about to fly. Get up, get up, get up. Okay? Do these stretchings. I'm giving you 3 minutes. Get coffee. It is required now. Okay? I will also get some coffee. Okay? Yeah. Cool. Let's begin. Okay. Let's begin the show. Right. All of you open Telegram channel, please. All of you open Telegram channel. From now on, I am not going to see YouTube comments. Answer. Take a picture of your answer and answer me in the Telegram channel. Okay. Let's start simple questions. Okay. Very simple questions. Let us say sigma is only one symbol. Yay. Okay. Fine. Sigma is only one symbol. Yay. Now sigma is only one symbol. Yay. Okay. Okay. Now language is A. Now give me three things: DFA, NFA, and regular expression. Draw the picture of your answer and give me the answer. Simple. A very simple question. Only one symbol is there in the alphabet, only one string is there in the language. I want you to do DFA, NFA, and regular NFA. I want you to give minimal DFA, minimal NFA, and a regular expression. Write your answer on the paper, take a photo of it, paste it on the Telegram channel. I'm waiting for your answers, guys. Write your answers in the Telegram channel. We are going to learn a lot from each other. Now I will see a lot of answers and I will explain you whether they are right or wrong. Okay. Come on, come on, come on. Fast. Okay, those who don't know the Telegram channel link, I'm giving you the Telegram channel link once again. Everyone join this Telegram channel. We are going to discuss GATE Computer Science and DA in the Telegram only. We are going to discuss GATE Computer Science and Telegram and GATE Computer Science and GATE DA in Telegram only, right? Yes, all the other subjects including computer networks will be on paid platform, right? Very good. So D has answered it right. Very good, very good. But D has missed out final states. D, check the final states. Monica, Monica has written this. Okay. So guys, have you joined the Telegram channel? Please join the Telegram channel first. Please join the Telegram channel first. Okay. 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 Now let me discuss all your answers. Why they are wrong, why they are right. Okay. So this girl, Monica, has given this answer, right? Now what does this mean? So whenever initial state, one more thing you have to understand is, whenever you make initial state as final state, epsilon is accepted. So this is wrong. In fact, you are accepting single A, two A's, right? So let me just explain you one thing, guys, before this. Okay, how to know whether a language is accepted by a finite automata or not? Okay, so let us say there is a DFA, right? A, B, let us say A comma B, B, let us say C, A comma B. This is a DFA. Okay. Now, how do you know whether a string is accepted by a DFA or not? Just give me some example. Let us say you have given me the string AB. Okay. Let us say you have given me the string AB, right? So A and then B. Initially, I'll start from A. Okay, cool. Now on seeing small a, I'll go to B. Cool. And B on seeing small b is going to be cool. So on seeing the entire string, I have started from initial state and ended in the final state. Therefore, this is accepted, right? Now let us see BA, right? So I will start from A. Cool, 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 cool. Now B, A, right? I will start from A. Cool. So A on seeing B is going to C, and C on seeing A is going to C. Now you started from initial state and you have ended in a non-final state. Therefore, this is not accepted. That is how you check the acceptance. Got it? This is for DFA. Let us do for NFA as well. Let us do for NFA as well. Okay? Okay? Cool. So for NFA, let us do this. Let us do this. Let me take an NFA state A comma B. Let us say A and this is B and it is this. Cool. Cool. Now let us see A, BA. Okay. Let us see BA. Okay. BA string. I will start from A. A on small b is going to A only. Cool. Right? And capital A on small a, capital A on small a is going to A as well as B. Is going to A as well as B. Right? I started from the initial state. Okay? I started from the initial state and I have reached two states. Okay? Now, one of them is final state. That is sufficient to say BA is accepted. Right? Now, let us see AB. Let us see AB. Right? So, capital A on small a, capital A on small a is going to A as well as B. Isn't it? Capital A on small a is going to A as well as B. So, it is going to A as well as B. Right? Right? Now, capital A on small b, capital A on small b is going to A, and capital B is not going anywhere on B, which means it is going to phi. So I ended up in A and phi. Both of them are not the final state. Therefore, AB is not accepted. Both of them are not final state. Therefore, AB is not accepted. AB is not accepted. Right? Right? Now you understood how a string is accepted or rejected by DFA and NFA. Let's get back to the question. Okay. Now what is the question, guys? Sigma equal to a single symbol, and the language is a single string A. I am asking you what is the NFA, minimal DFA and regular expression, right? Now Monica has given this answer. Okay. Monica has given this answer. What is the problem with this? Whenever initial state is equal to final state, first thing is epsilon is accepted, right? Now, if you see A, you are on capital A and you are coming to capital A, which is a final state, so A is accepted. Now, if you see A, capital A, you are going to A and you are going to A. You are starting from initial state and you are reached the final state. So, A is also accepted. A is also accepted, so on. This is accepting A star, Monica. Right? Cool. Who is this guy? Chrysobrel, you are right. Yeah. Okay. Yep. And then who is this guy? Sudesh. Sudesh, where is the final state, man? Without final state, you can't accept anything, right? Your DFA is right. Your NFA doesn't have final state. Very good. And Nitin, where is the final state? Acha, you have the final states. Okay, Nitin, very good. Okay, but you didn't give the regular expression. Try to give the regular expression. Okay. And why did you write so many strings? Okay, cool. Okay, guys. Okay. Now, what is the simple NFA and DFA? So, sigma equal to a single symbol, and the language equal to a single string. Now, what is the NFA, DFA and regular expression? Regular expression is very simple. Whenever the language is finite, you don't have to do anything. Just put a plus, right? So, here there is only one string. So, I can say regular expression is a itself. A represents a, that's it. Okay. Now, let us try to do DFA, right? Let us try to do minimal DFA. Now, why am I saying minimal DFA? Because I have a lot of practice, I can directly do minimal DFA, but you will not be able to do directly minimal DFA. Okay? With practice, we will be able to do minimal DFA, right? So, hmm, 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 hmm. Minimal DFA is, I will start from the starting state, cool, cool. I have to accept a, cool, I will accept it, right? This is state A, this is state B. Is this the answer, guys? I am accepting A. Is this the answer for minimal DFA? No. Why? Because sigma has A. You said what happens to capital A on seeing a small a? What happens to capital A on seeing a small a? But you didn't say what happens to capital B on seeing a small a. What does that mean? If I get one more a here, I am seeing two a's, I should not accept it. Okay. So, one more a here, I am going to capital C, I am not going to accept it. Right? 1a I accepted, 2a's I rejected. Is this the DFA, guys? No, no. Why is it not the DFA? Because for C also you have to say what happens if you get a, right? So, if I get any number of A's, I will be here, right? This is a special state. Once you reach C, you will never reach B. The states from which we will never be able to reach the final states are called dead states. The states from which we will never be able to reach the final state are called dead states, right? So even in this example, let us see this, okay? See this example. Once you reach C, there is no transition to go to B. There is no path to go to B. Therefore, C is a dead state, right? C is a dead state, okay? Now, this is the DFA, guys, okay? This is the DFA, okay? And this is the minimal DFA. You cannot reduce the number of states further. Now, I want, what is the minimal NFA? What is minimal NFA? Simple logic, you have to accept A, accept it, okay, cool. I am accepting A, cool, right? Now, in a NFA, there is no restriction that you have to put transition for every state. So, you don't have to put any transition for B, you can leave it like that, right? So, basically one simple concept we can learn here is, do the minimal DFA, remove the dead state. In most of the cases, that will give you the minimal NFA. So, this is the regular expression, this is the minimal DFA, this is the minimal NFA. Everyone liked it? Everyone liked it? But very few people have answered. I think only 4 people have answered it. Even though 80 people are watching it live, only 4 people have answered it. Right? Try to answer, guys, okay? Now, let me give you one more question, okay? Let me give you one more question. Let me increase the complexity a little bit. Sigma equal to A, language equal to A. Now you do DFA, NFA for this and the regular expression. You do DFA and NFA and regular expression for this. You do DFA and NFA and regular expression for this and write it in the Telegram channel, okay? Write it in the Telegram channel. Yeah. No one is answering it in the Telegram channel. There are 100 people here. No one is answering it in the Telegram channel. Try to answer it, guys. Okay. Shall I do it? You have to accept 2a. See, regular expression is simply when there is only one string, that string itself is regular expression, right? Now, what about DFA and NFA? See this. So, I am talking about minimal DFA. On seeing a single A, I will wait for one more A, and if I get two A's, I will accept it. After that, any number of A's come, I will kill them. I will send them to dead state and they will be trapped there. So, for every state on input A, I have told what to do, right? So, this is minimal DFA. Now, how do you convert it to minimal NFA? Simple logic. There is dead state, remove it. Now, whatever you get is the minimal NFA, right? So, one thing that you have to observe here is the number of states in minimal NFA is always less than or equal to the number of states in minimal DFA. Why do you think this logic is right? This logic is right because if the minimal DFA contains dead states, you are going to remove them. Therefore, number of states in NFA will be less than DFA, and even if you find a minimal DFA, you can call it a NFA also. Therefore, minimal NFA will also be having equal number of states. Are you getting the logic? Okay. The number of states in minimal NFA, this is a question asked in GATE. Okay. The number of states in minimal NFA is less than or equal to number of states in minimal DFA. Why? Why? Very simple logic here. If there are any dead states in DFA, I will delete it. Therefore, NFA will be smaller. Let us say there are no dead states. Then I will cheat. What I will say is, whatever minimal DFA you made is also a NFA. Therefore, that is also minimal NFA. Therefore, minimal NFA will never contain more states than minimal DFA. It will always be less than or equal to. Okay. Now, exactly how much number, that we will discuss. Okay. Cool. Someone has sent the answer. Monica, very good. Monica, 2A's you are accepting, 3 and 4A's you are rejecting. Okay, very good, Monica. Monica, regular expression is not A plus A. Okay, it is a single string AA. Okay, it is a single string AA. Right? Now let's do this question. Sigma equal to A and the language equal to A. We are just flexing. Give me minimal DFA, minimal NFA and regular expression. Give me minimal DFA, minimal NFA and regular expression. Guys, those who are preparing for GATE CS, please do prepare for GATE DA also. Those who are preparing for GATE DA, please prepare for GATE CS also. When you prepare for both of them, you will have wider options open. You can easily get into some IIT because you have two options, right? Don't restrict yourself, right? And also my charges are very low, right? I'm going to increase the fee. Now still the early bird offer is going on. Just register as soon as possible. Okay. Yeah. Any answers, guys, in the Telegram channel? Any answers in the Telegram channel? Anyone is answering in the Telegram channel? Simple, na? Right? So regular expression, there is only one string, therefore I will write that string. Fine. Okay. Then I will try to do minimal DFA, or you can also do minimal NFA first, no problem. A accepted, I mean 3 A's are accepted. So 0 A's not accepted, 1 A not accepted, 2 A not accepted, 3 A's are definitely accepted. Okay. Now if I get one more A, 4 or more A's, I will reject. I'll kill them. I will take them to dead state and kill them, right? Cool. This is minimal DFA. What is minimal NFA? Remove this. That's it. Remove that. Cool. Cool. Now I will just increase the complexity a little bit. Okay. Sigma, let us say, is equal to A. Okay. And the language we have is A. Now give me NFA, DFA and everything. There are two strings in the language. You have to accept both the strings. There are two strings in the language and you have to access both the strings. Yeah. Yeah, guys. Simple. What is that you have to accept? 2s and 3s, right? So what is the regular expression, guys? For this, the regular expression is A. For this string, the regular expression is A. It is union of two strings, so I will put a plus. Don't worry about regular expressions. I will take detailed class about it. Okay. Now let us say minimal DFA. Let us say minimal DFA. Right? Okay. So I have to accept A and I have to accept 2A's, right? I have to accept 2A's. 0A's, 1A, 2A's. Accepted. 0A's, 1A, 2A's. Accepted. I have to accept 3A's. But if I put A here, it will accept 3A's, 4A's, 5A's, everything, right? So don't do that. Don't do that. Put a new state and you accept 3A's. This is 3A's. And then whenever you get one more A, which is 4 or more A's, 4 or more A's, you are going to kill them. You are going to kill them. This is minimal DFA. And if I remove this dead state, then it will become minimal NFA. Simple. Minimal NFA. Right? Minimal NFA. Right? Right? Now, answer the next question. Let us say input alphabet sigma equal to A. Okay, someone has answered it. Sunil, very good. Okay, so language equal to A, language equal to A, 2A's and 4A's. You have to accept 2A's and 4A's. Use the regular expression, minimal NFA and minimal DFA. Okay. Use the regular expression, minimal NFA and minimal DFA. Use the regular expression, minimal NFA and minimal DFA. Write it in the Telegram channel. I want to see your answers. Okay, someone has written. No one has written. Okay. No one has written this. Yeah, someone has written. Good. Good. Very good. 2A's and 4A's, right? Who is this? Kirutika. Kirutika. Very good, Kirutika. Your answer is right. Okay. Kirutika, you are right. And Divi, you are right. Divya. I think Divya. Divya, you are right. Cool. And Chrysoberyl. Yes, you are. Chrysoberyl, why is your answer like this? Yeah, you are right, Chrysoberyl. Very good. And Manu, you are right. Very good. Sunil, you are right. Sunil, I think you have put a loop. You are accepting. Whenever you put a loop, it will go to infinite language, right? So understand that. Yeah, Manu, you are right. Sanet, I don't know why you put two paths. It is not a DFA, right? Because on a single symbol A, you are going to two states. That is not a DFA, Saket. Cool. SDS, right? Monica, you are right. Cool. Sudesh, you are right. Cool. Shubham, you are right. Cool. Priyanka, no. When you put a loop, it goes to infinite language. Sunil, you are right. Yeah, Sunil. Yeah. But then why are you putting loops, guys? That will go to infinite loop, right? Yeah. Kushi, you are right. Cool. Okay. Fine. Let's see this, guys. So simple. Regular expression is going to contain A plus A. There are two strings only. I can write like this. A, right? Cool. Cool. Now, let us say minimal DFA. Okay. Minimal DFA, right? Minimal DFA is going to be 0 A's, don't accept it. 1A, you accept it. 2 A's, you accept it, right? So 0A, 1A, 2A. 2 A's, you accept it. 3 A's, don't accept it. And then 4 A's, this is 4 A's, right? 1, 2, 3, 4, accept it. And then any number of A's, this is 5 A's, and then more A's. 5 A's or more, you kill it. We have only two accepting states, right? So this is the minimal DFA. And what is the minimal NFA, guys? Remove the dead state, that will become the minimal NFA, right? That will give you the minimal NFA. Right? Now, answer me this question. Sigma equal to A, sigma equal to A, language equal to set of all words such that number of A's in the word, is even, which means I want even number of A's, right? So 0 is even, 0 is even, right? 0 is even, right? So epsilon is 0. A is even, 2A's are even, A is even, 4A's are even, A are even, 6A's are even, so on. So this is the language that I want to accept. Can you give me the regular expression, and can you give me the regular expression? Can you give me the regular expression? And can you give me the DFA and NFA? Okay. I'm seeing your chat. Just take 2 minutes and answer this. Just take 2 minutes and answer this. Okay. Hmm. Very good. Many of you have answered. Yeah, cool. Hmm. Cool. Manu, you are right. Hmm. Divi, you are right. Div, you are right. Sudesh, right. Kritika, right. I think I don't have to teach here. Everyone is right. Nitin, you are right. Sanket, why did you take 3 states? Everyone have done it right. Everyone. Monica, Onkar. Onkar, your answer is interesting. Onkar, I will discuss about it. Okay. So Onkar has done this. His answer is right, but yeah, but it is not minimal, right? Okay. So I will say Onkar's answer. Okay. So what did Onkar do is, since epsilon has to be accepted, initial state should be the final state. And what he did is, 1A he didn't accept it, and second A he accepted it because it is 2A's. Now 3A's he didn't accept it, 4A's accepted, 5A's didn't accept, 6A's. So it is right, right? So this is right. But then this is not minimal, right? That is the problem. Okay. So you can reuse this final state. So what is the best answer? Epsilon has to be accepted and 1A don't accept, 2A's accept, 3A's don't accept, 4A's accept. So this is the minimal DFA, right? And you cannot reduce any states. That is why it is the minimal DFA. And even if you try minimal NFA also, you will get the same, right? So minimal NFA is also same, right? Now, what about the regular expression? See, if you observe this, every string is made by AA. Every string is made by AA, right? Therefore, I can take AA and I can put a star. If I put 0 here, I get epsilon. If I put 1 here, I get A. If I put 2 here, I will get AA. So on. So it is AA star. It is AA star. It is AA star, right? Cool. Nice. Very good. Guys, can you guess what is the next question? You only guess it, you only answer it. I will not do anything here. You only guess it, you only answer it. I will not do anything. What is the next question, guys? What is the next question? Very good, Sudesh. Obviously, someone wants Telegram link. Can you please send the Telegram link? Someone. What is the next question? So even number of A's is done. Therefore, what will be the next one? Obviously, odd numbers. You are only doing even numbers. You are only doing odd numbers. You are only giving the question and you are only giving the answer, right? In the website, the video will appear tomorrow. Okay, don't worry. The video and the notes and the handwritten notes, everything will be in the website by tomorrow. Okay, tomorrow we are going to take that. Yeah. So guys, next question is sigma equal to a. Sigma equal to a. Let us say the language is A's or odd. A's or odd. What do I mean by that? There can be 1A or 3A's or 5A's or 7A's or so on. A's or odd. 1A, 3A, 5A, so on. Right? Very good. Someone has already sent the answer. Cool. So Manu, you are right. Cheryl bro, you are right, but you are but you are not giving the regular expression. I think you are facing some problem with the regular expressions. I will conduct detailed section about regular expressions. I know this is difficult. Okay, don't worry. I will conduct the yeah. I'll give you a planner. Don't worry. Okay. So basically, now what we are going to do is we will see TOC and then we will see discrete mathematics, only part of discrete mathematics, the counting, because I need counting in combinatorics, right? So in discrete mathematics there is combinatorics. So I will do the combinatorics so that you will be able to answer counting questions in TOC and other subjects. And for gate DA, probability, right? So these two are going to start from Wednesday, right? So the timings will be from 6 p.m. to 8 p.m. or 6 p.m. to 9 p.m. and then the TOC timing will be from 9 p.m. to I think 12 p.m. 12 a.m. Okay, these are the timings: 6 to 9, 9 to 12, right? So here we are going to cover both DS and CS, right? So we will finish TOC, and after finishing TOC we will do DBMS because it is very easy, and algorithms is very easy, data structures is very easy, uh, and then what else? Yeah, and then we will do the remaining subjects, but I will do CO at the end because you will forget it. So I will do CO at the end so that you will remember before the exam. Okay. And for gate DA, probability will start, and after probability linear algebra, and after linear algebra calculus. Okay, and then the remaining topics. Anyway, all these are common in DA and CS also except TOC, right? Okay, yeah, okay, cool. So you are finding problem, Monica. I think everyone is finding problem in writing the regular expression. I'll tell you. Okay, so 1A you have to accept it. Okay, and 2A's you are not going to accept it. 0A's you are not accepting. 1A, 2A, 3A, 4A, 5A, 6A. So all the odd numbers are getting accepted here. So this is the minimal DFA as well as minimal NFA. This is the minimal DFA as well as minimal NFA. Cool. Minimal DFA and minimal NFA, you got it. Now the only problem is, what about the regular expression? Some people have given A star, but the problem with A star is it has epsilon, it has A, It has A. Even two A's are also coming in A star. So it is not the right answer. Someone has given A plus. In A plus, you will get A. You will get A. Again, two A's are coming, right? So it is not the answer, right? And what are the other answers that you have given, guys? Hmm. Yeah, someone has given this answer. Yeah, Chernobyl, you are right. Monica. Monica has given answer like this. A plus followed by A plus A. Very good, Monica, you are right. Okay. You are right, Monica. Okay. Which means you are taking even number of A's and joining A, which will give you odd number of A's. But then the minimal here you get is A, because here the minimum value I can put is 1. Therefore, you are getting 3 A's. To compensate that, you have added 1 A. You are right. This is a right answer, Monica. Okay. Okay. But if you take the same answer, guys, if you take the same answer, Monica has given like this. Okay. So if you take the same answer, you try to pull out A as common from the right side. Then what do you get? A plus epsilon followed by A. Now what is A plus epsilon? Here you put 1, you are going to get A, right? If you put 0, you are going to get epsilon. So together I can write it as A star. Because if I put a 0, I'll get this. If I put 1, I'll get this. 2, 3, 3, everything I get this. So this is it, right? So you first create, so you first create even number of A's, okay? A star, and then put a that will become odd number of A's, or you can also write this A followed by A star. You will get, if you put 0, you will get 1A. If you put 1, you get 2A, 3A's. If you put 2, you get 5A's, right? Right? So it is simple, right? Right? Yeah, Divi, you understood it right now? Okay, okay. Now what could be the next question, guys? Can someone guess the next question? Can someone guess the next question, please? Can someone guess the next question, please? Okay, I'll give you the question. So let us say sigma equal to A, okay, and let us say language equal to set of all strings W such that number of A's in W are divisible by 3. Number of A's in W are divisible by 3. Earlier even means divisible by 2. Now here divisible by 3, right? Right? No, so no, it is right. She didn't add plus. Acha, has she added plus? No. Power plus, right? It is right. So no, she is right. Monica is right. That is one other way of writing. So for a given language, there can be many regular expressions, and one answer is given by Monica. That is right. There is nothing called minimal regular expression. No one will ask you what is the minimal regular expression, because there is nothing like minimal. There can be many regular expressions, okay, and there is no way to minimize them. So no one will ask you write the minimal regular expression, okay. But regular expressions are very important because they can be asked in MSQs, okay. So we are going to focus on regular expressions a lot, okay. We will do thoroughly regular expressions, okay. Yeah. Someone please give the Telegram channel link to Ankit. Someone please give the Telegram channel to Ankit. So, Kirutika, you are right, but the problem is you are accepting the epsilon in NFA and DFA, but you are not accepting epsilon in regular expression, right? Don't put plus, put a star, okay? Don't put plus, put a star, okay? Why four states? That is multiple, that is different. SDS, you just need three states, right? You can do it with three states. Everyone is trying with four states. Acha, you are thinking that Sanket, your regular expression is right. Epsilon is in the language. When epsilon is in the language, initial state would be final state, right? When epsilon is in the language, initial state should be final state. Everyone is doing four states. I don't know why. Everyone is doing four states. I don't really know why. I don't really know why everyone is doing with four states, but yeah. So divisible by 3 means write the language, you'll get some answer. Epsilon 3A's, 6A's, so on. Epsilon 3A's, 6A's, so on. So what will be the regular expression? A is the building block and epsilon is also there. So the regular expression is A star. When you divide any number with 3, there will be 3 reminders. That is why there will be 3 states. When you divide any number with 3, there will be 3 reminders, right? Therefore, there will be 3 states. There will be 3 states. Now, what are the 3 states? Good. So, when epsilon has to be accepted, so initial state is final state. So when I divide a number with 3, the remainder can be 0 or the remainder can be 1 or the remainder can be 2. So I'll have 3 states. One state remainder is 0, one state remainder is 1, one state remainder is 2, right? If I get a single A, the remainder is 1. If I get 2 A's, the remainder is 2. If I get 3 A's, the remainder is 0. Remainder is 0, remainder is 1, remainder is 2. So 0 A's, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, so on, so on, so on, right? Therefore, all the numbers that are divisible by 3 are getting accepted, right? And then this is the regular expression, right? Okay, fine. Now tell me one thing, guys. Now tell me one thing. If I say number of A's in W is congruent to 1 mod 3. What is the meaning of this? Number of A's in W is congruent to 1 mod 3. What is the meaning of this? It means that if I divide the number of A's by 3, the remainder should be 1. Then what happens? Then this will not be the final state. This will be the final state because it is representing remainder 1, right? If I say number of A's in W is congruent to 2 mod 3, if I say 2 mod 3, then this one will not be the final state. This one will be the final state, right? Right? Got it? Okay, cool. I will give you a very, very interesting question. Gate PYQ. Try to answer this, okay? I'll give you a very, very interesting question, okay? Try to answer this. Okay. So, language equal to, let me give you the regular expression. A plus A star. Language equal to A plus A star. Lakshay, I will take the live lectures and the recorded version of these live lectures will also be available to you, right? It is not just live plus recorded. Yeah. Very interesting question. A very interesting question, right? So one thing you have to understand is A plus B star is not equal to A star plus B star. A plus B star is not equal to A star plus B star. Actually, this is 2A's and this is 3A's. So, what are all these strings you can make using 2A's and 3A's? This language is actually equal to A power n such that n is equal to 2x plus 3y. A power n such that n is equal to 2x plus 3y. That is the language. A power n such that n is equal to 2x plus 3y. Tomorrow I am going to give you 100 practice questions, okay? In the every day almost we will give you 100 practice questions, okay? In the PDF format. We will type the questions and give you, and on the next day you will get the solutions to all the questions. I want to give you 1 day time to solve, and every day almost you will get 100 questions, okay? So try to spend more time. So by the time I finish TOC, your TOC should be done. All the practice questions should be done, right? I'll give you 100 questions tomorrow, okay? It will be for the paid users, not for everyone. Yeah. Okay. So this is equal to A power n such that n equal to 2x plus 3y, which means either you can use the 2a's or 3a's and you have to build, okay? You have to use 2a's or 3a's and you have to build. You have to use 2a's or 3a's and you have to build. Okay, so no one is able to answer this because you are not writing the language, right? Yeah, you have answered it. Who is this guy? Cool. Jahnavi. Janhavi. I think Jahnavi only. Janhavi Nayak, very good. You answered it in the right way. Okay. And also Nitin, you answered it in the right way. Very good. It can come in MSQ. Okay. I will show you why it can come in MSQ. Okay. Fine. Now just try to write what is the language. Okay. So a star is here. If I put a 0 here, epsilon will definitely be in the language. Using 2a's and 3a's, I can never make 1a, right? Epsilon is in the language. I will not get 1a, but I will get 2a's because I can use this to get 2a's. One time, if I use this one time, I get 2a's. and if I use it one time, I get 3A's. And if I use it two times, how can I use it two times? I will put a 2 here. A plus A concatenated with A plus A will give you 4A's, right? So A power 4 is possible. Now if I use this one and this one, how? I will put a 2 here, then I will take AA here and AA here. So A power 5 is possible. If I take 3, A power 6 is possible. If I take A power 7, how do we get A power 7? I will use this two times. 4 plus 3 is 7. A plus 7, and then A power 8 is possible. I will take this 4 times. So everything is possible, right? What is the only thing that is not possible here, guys? What is the only thing that is not possible here? So only thing that is not possible here is A. Except A, you have to accept everything, right? Therefore, accept epsilon, fine, accept epsilon, fine. Don't accept A, okay? Don't accept A. Single A is not there, but two A's are there, accept it. 3A's are there, 4A's are there, 5, 6, 7, 8, everything are there, so accept it. Cool, over. This is the answer, right? So this is the minimal DFA, and there is no dead state. You cannot minimize it. So this is the minimal NFA also. Okay. If someone can give me one more NFA, if someone can give me one more minimal NFA, I will give you the course for free. If someone can give me one more minimal NFA, if someone can give me one more minimal NFA, I will give you the course for free. I will give you the course for free. Give me one more NFA. I am giving you 5 minutes time. Give me one more minimal NFA, okay? Give me one more minimal NFA. This question can be asked in MSQs. This is a minimal NFA. You will get one more minimal NFA. If someone can give me, one more minimal NFA, I will give you the course for free. Get CS plus DA for free. Wow, cool. Monica has given it. Who is this? Monica. Very good, Monica. And yeah, you will get the course for free. Monica, please do please do reply to our WhatsApp business. You will get the course for free. Very good, Monica. Excellent, Monica. Excellent. I love your answer. Monica, please do WhatsApp on our business number. We will give you both GATE, CS and DA for free. Okay? Okay? Yeah. So guys, how are you going to solve this? So you can use 2A's or 3A's, right? So definitely epsilon is there. I'm going to put a this one. Initial state is final state. And then 2A's. So 2A's or 3A's. You can make anything with it. If you want 2A's, take this. If you want 3A's, take this. If you want 4A's, take it 2 times, 4A's. If you want 5A's, take it and then take it. You are going to get 5A's, right? You are going to get 5A's. So this is also a minimal NFA. This is a minimal NFA with 3 states. This is also a minimal NFA for 3 states. That is what I am telling you. Minimal NFA need not be unique, right? The minimal NFA need not be unique. See, this is okay, this is a DFA, right? And I can call it NFA also. So it is a minimal NFA. And I got one more NFA, minimal NFA, but this is not a DFA. Why is it not a DFA? Because if you observe this state on seeing a, see this state on seeing a is going here, and also on seeing a is going here, right? You can't go to two states in a DFA. It is clearly an NFA. This is only minimal NFA. This is both minimal DFA and minimal NFA, right? Right? So guys, the fee is going to be increased to 31,000 very soon. Please try to register the course as early as possible, okay? See you tomorrow again at 9 p.m. Okay? I hope you loved this session. So your day has started with me. Now the day has started, right? It is great that you are starting the day with me. Thank you all guys. So see you tomorrow. So this entire lecture notes will be available to you in the app. The video will be available to you in the app, and also a handwritten notes is going to be available in the app, and also a typed notes is also going to be available in the app. You can use any of the three that you have. Okay. Okay. Fine. Thank you guys. See you. See you tomorrow. Bye. Take care.